in producing concrete? So how do you control the usage of water? Because according to Abraham's law, he said a 1% increase in water, it reduces concrete strength by 5%. So that means water is enemy of concrete. So how do you manage the usage of water in producing your concrete, sir?
Okay, sir, good evening once again, everybody. So for water and concrete, we all know the constituents of concrete is cement, water, air, sand, and the coarse aggregates, of course. But like you mentioned, water is actually very important in concrete because it does two major roles. First role of water in concrete is for hydration of cement. Cement in itself will not hydrate except you have water. Bearing in mind that water is from three states, we have it as solid, liquid, and gas. So at times when you put a cement by the side and you see that it has caked, it's because water in one state or the other has gotten into that cement and it has made it cake. So that's the hydration process of making cement harden. It's called hydration. So water is for hydration in concrete. And also water is also needed for workability in concrete. So for two basic things that water is needed for in concrete is hydration and also for workability. So if you look at also to measure water in concrete, we have a term called the water cement ratio. I'm sure we are all familiar with this. And for the first part, which is hydration, you only need 0.32 or to 0.35 water cement ratio to ensure water is enough for hydration in concrete. So if you see a mix for, say, people making capstone or people making blocks, you see that they are very, very low water mix, dry mixes, because the water they need is just for hydration. They don't need any water for workability in such mixes. So you see that that water is controlled. And like you mentioned, Engineer Oladapo, the more the water cement ratio, the lower your strength in concrete. So to go back to your question to say that how do we control water in concrete? Definitely according to the BS standard, BS 8110, there is always for any particular grade of concrete, there is always a maximum water cement ratio. If you check BS 8110 and also if you check the BS 5900, so you will see that there's a maximum water cement ratio, which should guide us as engineers. So using the code, which is the standard of practice for all of us in engineering, the code guides you for whatever grade of concrete you want to do and whatever type of workability you want to do. The code gives us a guide to actually help us achieve the water cement ratio, the strength required as specified, and for whatsoever means you're using the concrete for, or whatever workability you're using the concrete for. So I think that's where I would want to leave this, because we all work on the basis of the code. So if we look at BS 5900, which is the new EN, or the BS 8110 we use in school, gives us an idea of the maximum water cement ratio we should use in our mixes. So thank you so much, sir.
Thank you so much for doing justice to that question. Engineer Kolade, over to you, sir.
All right, thank you so much, Engineer Shola. Actually, I will still be coming to you. In the case where you are transporting the concrete to a distant area, so what do you do to ensure that the workability of the concrete is not tampered with?
Oh, okay, sir. So thank you so much. I think workability is, if permits me to define, is the ease with which you can mix, place, and finish your concrete. So if you are pumping concrete, then it means that your concrete needs to have a slump minimum S3, S4. S3, S4 means slump of S3 will be 150, S4 is like 180 slump for you to pump it. So if I'm transporting concrete from, say, Lafarge Ikeja to Lekki, it might take me 1 hour to transport. And also it might take me, if I'm pumping a pile now, let's say CFA, if I pump the concrete into the pipe, it might take me another 30 minutes. That's 1 hour 30 minutes. Then with CFA, I need to place a cage, and that cage must able to move into the concrete. So that will take me another 30 minutes. That's 2 hours for me to make this concrete. Still give me S3, that's 150 slump at that point. But like we all know, concrete adding, then it sets also. So workability will definitely reduce. So there's a need to put in place a slump loss to say, okay, I will lose this slump, but what can happen? But that's, you measure the initial slump at the point of mixing. Then at the point of placing also, you measure your slump needed to put your cage or to place. So to get all of this thing done, there are many options. Like I mentioned, water is needed for hydration. It's also needed for workability. So the easiest option, which is what most people do, is to put more water at the point where it gets to site to ensure that the concrete flows. I was speaking the Yoruba way, they say, that's the ideal method people use in the normal standard practice in our industry for now. But like we all know, the higher the water cement ratio, the lower your strength you would get. So by adding that more water, you are reducing the strength. So that's option 1. Option 2, which is not a no for me on my own side, except you factored using your minimum water cement ratio in the first place before adding this up. Like remember, I mentioned the case of the BSEN. If you've used 0.4 on at the point of mixing, and by the time you get to site, you have a factor of safety that takes it to 0.5, then you can add more water to meet up with that, just to ensure that you get the strength based on your existing trial mix design. All of this will have been done in the trial. The other option is to put a super plasticizer, add mixture or super plasticizer. There are different types of admixture. So I would say super plasticizer type G type. That means it can reduce water and it can retain workability. That's slump retention. So if you get 180 at the point of mixing, say in Ikeja, by the time you get to Lekki, it can retain that 180 to say 170 at the point of placing into your pile. And by the time you're putting your cage, you lose another 10. So you still retain that slump from 180 to 160. Ideally, without using those products, you might not be able to get such, as we all know. So if you see Lafarge truck, he has a super plasticizer with set retarding property on the inside. Or if you see Julius Berger truck transporting concrete, he has this on the inside. So the other option is to use a plasticizer and also a retarder, because a retarder is a separate product. It can, if you dose too much, then your concrete might not set eventually. But once you do your trial mix, you can determine the quantity of retarder you can place per time. So, but ideally for most companies, if you have already mixed truck or you're about taking for a longer time, you have a small quantity of plasticizer on the inside of your mixing of the mixer lorry. Just to make it simple, a plasticizer is known as a water reducer. So remember, I said you can add water on site, but rather than add water on site, you have a water reducer, which removes the need for you to add that water. So that's the job of a plasticizer. It prevents you from adding more water on site. It reduces your water cement ratio. So a concrete with plasticizer tends to give you more strength compared to a concrete without plasticizer. And there are different types. There are ones depending on the water reduction percentage, 20, 30, 40, 50% water cement ratio you can reduce. And like the facilitator has mentioned, if you can reduce by 1% your water cement ratio, if you can go from 0.4 to 0.5, it can give you as much as 20% gain in strength. So thank you so much, sir.
All right, thank you very much, sir. I must say you really did a more than justification to that question, and we really appreciate that. And that's why we are dealing with Veteria. All right, now we're going to Engineer Giwa. Engineer Giwa, like I asked earlier, I asked Engineer Shola earlier that what will he do if he's transporting his concrete to a distant area and is no longer workable, or what will make it workable? So now, to you, as a concrete user, what do you do if the concrete delivered to your site is not workable? At that point, as a leading engineer on site, what proactive measure will you take to ensure that you achieve your desired goal, and the strength of the concrete, the workability of the concrete is not tampered with?
Yeah. Good evening once again. Uh, I like the way you phrase the question by saying that what is the proactive measure that we are going to put in place. So rather than saying what is the mitigation plan, so because it has to be proactive. There is a quality control standards in any organizations. As far as we are concerned, we have quality control team. So, and our quality control people, they always, well, when we start a project, they always synergize with our vendor. The vendor also has their own quality control, because Engineer Shola has rightly said that if you want to increase the workability, you dose it with fertilizer instead of you putting more water that will reduce the strength of your concrete. So now, the reason why we normally synergize with them is because they are the one giving the fertilizer. Any truck coming, they are going to give them fertilizer so that when they come to the site, and the reason why I said when they come to the site, we can be able to use the fertilizer if needs be. So, and the reason why I said I like the way you phrase your question as proactive measure is because if a truck should come to my site, to our site, everybody knows that they shouldn't start pouring immediately. The quality personnel, they will go there. The person in charge will go there to check, to see if the workability of the concrete, the flow of the concrete is enough for what we want to use it for. If it is okay. If it is okay, there's no need of putting fertilizer or putting anything. So we pour it immediately. But if there is, if maybe by the time they are transporting it, as he said, maybe there's traffic on the way, the retarder they put couldn't retard it to that extent, then we have to dose it with fertilizer. And it's not like we dose it like that, because all the fertilizers, they have their own data sheets. And it is being given by the vendor. That's why I said our team synergize with them so that they can educate, because the answer is education. We educate our people, not only the quality control people, even the people on site. They know that they shouldn't discharge any concrete until the quality personnel comes to the concrete and check if it is workable enough for that particular work. I have a lot of things to say as far as that is concerned, but because of time, let me, if there's a question around that, so I will still attend to it. Let me stop from here.
All right, thank you very much. Okay. Briefly, I will be sharing a video with us for a few seconds.
Yes, well done, Engineer Kolade. Yeah, while we are waiting for the video and while we watch, Engineer Giwa, I want to put this question to you. As a project manager, as a construction engineer with diverse years of experience, and I know you to be a versatile engineer, I want to put this question to you. Now, in some small-scale concreting, where concrete casters are commissioned for work, how can the risk of excessive water proportion can be controlled? What do you think? For instance, if you can check this video, take a look at the video that will be shared. We have not seen the video.
Or can you see my?
we can see your screen. Kindly share the video so we can see there are a lot of errors. Yes, we can see the video now. You can see there are many wrongs in this video. So, Engineer Giwa, what do you think we can do to mitigate such things?
Thank you, Engineer Oladapo. Yeah, as I said earlier, sensitization and training of the member is very key. And I know where your question is coming from. Firstly, let me put it this way. It's always good if the engineer that is doing the casting, that is in charge of the casting, have his own mixer. But in a situation whereby you are using caster and we know our environment, I will not pretend as if I don't know our environment well, that the caster won't want you to detect the amount of water he's going to use for you. What I normally do is to engage them where I normally use this kind of concrete mix, stationary concrete mixer. I will engage them, tell them my own terms initially. Let them understand that this is how I normally mix my own concrete. I don't put water too much. This is the kind of, if it is a trial mix that I've done that require us using different sizes of coarse aggregate, I would have let him know this amount of coarse aggregate I'm using, this amount of this size, maybe half inch, 3/4. I'm using this kind of percentage for 3/4. I'm using this kind of percentage for half inch. I would have let him understand what I want to do prior, and I will tell him I will put a checker. I will put someone. I will station someone with him to make sure that all the ratios are being followed. So it's what I've done, and I achieved it with that. So I have so many casters. There are some I say, no, it will spoil our machine, it will do this, it will do that. If you know that you cannot do it, go. So now there are some casters that say, okay, but when the work starts, they might want to, but because of our station someone there, that is own work throughout the casting period. We monitor it. And as engineer Shola rightly said, the hydration process, the amount of water it requires is not that much. But for the workability, that's it. You know, and when we are talking about workability, it's two things. It's two things, but the most important thing is how you want to make sure the concrete is well compacted. So if you have several means of making your concrete compacted by using, like I normally tell people, when you are casting concrete, there is a way you set your focal vibrating machine. So you can set it to be low or to be high at medium. Some people doesn't know how to use that focal machine. It depends on the kind of concrete you are pouring, you are casting, that will make you to set the focal machine. Once you have that kind of tools to use to compact your concrete well, then you can say this is the amount of water cement ratio I want to use based on your trial that we have done, and you know that it has given you that grade in the lab. So that's training is very key, and you have to train your people as well, because even your messing is your messing that will be shouting that tell that caster to increase the water. But once you have trained your messing prior casting, like we don't need the water to be too much to achieve strength, and you let them know the impact of water when the water is too much on concrete. So I believe, let me stop from here because of time. If there is another question that I can still expatiate further. Thank you.
Yes, thank you, sir. Everyone raising up your hands, we still get to where you will add your voice to ask your questions. Engineer Shola, Engineer Giwa, I have a particular question to ask you in placement, curing, and transporting of cement. I'm still coming, so I have a question for you on that. Engineer Shola, I want to quickly ask you this question. In an instance, what can be the possible causes of concrete losing strength? For instance, let's assume a concrete cube sample was crushed and has 29 Newton per mm square at 7 days, but 28 days the strength is lost and it has 25 Newton per mm square. What do you think can be the probable cause of that? Thank you, sir.
Okay, thank you so much once again, and welcome everybody once again. So ideally, concrete from our school teachers, concrete is supposed to gain strength with age. That's from 7 days, it's supposed to increase in strength with age. So probably, if this is not happening, one of the issues could be wrong sampling. Maybe the samples were not taken properly. It's the major issue that happens for such case. Other case might be the fact that the samples are not properly cured. That could be another case. Another case could be that it was improperly cured in an unsafe environment. I will give an example. I've had this issue before, and the guy told me that no, at 7 days we had 25, which is supposed to be 70% or 65%. But 28 days, we were hoping we'd get 30. We didn't get 30, we got 26. Eventually, when we got to know, the water they were using to cure had some chloride on the inside. So this did not actually help us to achieve the strength. But the fact that the strength reduced, no, he just gained additional 2 MPa. But eventually, when we found out, we saw that when we broke the sample and we had a look at the samples. So aside crushing your cubes, you need to look at the fracture of your sample. We realized that there were a lot of void inside of this cube. How can you know? Even by getting your weight alone, we realized that the weight was even lower than the weight of the other cubes. So we understood that there were voids in this concrete. So in the long and short of this is, let's also pay attention to taking samples. Taking sample is more important than breaking the cubes. If you don't take the sample right, if you don't do the 3 layers, if you don't compact them based on the BSEM standard, then you might still have issues because the cubes will be lighter. They are not well vibrated. If they are not well stored, then you still have the same issues of getting the wrong strength. So basically for me, I would say it's more of we as engineers, not leaving our faith like Engineer Giwa has mentioned, and the fate of caster in the hands of casters, and taking these samples by ourselves. It is actually very, very important we take this sample as ourselves, so at least it's a true reflection of the slab we have in there. Thank you so much, sir.
All right, thank you very much, Engineer Shola. That was a brilliant one. Okay, I would like to ask Engineer Shola as well. So, we've been talking of concrete here, and practically we've been talking of concrete produced with mixers and sophisticated equipment. So now, can we equally get a workable and effective production of concrete through hand mixing? That it will perform effectively as that which we will get using a concrete mixer.
As I would agree with you 100% that we can get good concrete with the hand. Like I say, and like we all know, quality is priority. You cannot avoid quality and say you want to meet your priority. It's a no-no. It's possible. I told somebody to say that if your quality is right and you can measure all you put, if you do the trial mix, first it comes with doing a trial mix. If you do a trial mix, let's assume you come to me or I come to you, I want to do this in 3 minutes. And you say you want a grade 25. It's designed by Engineer Giwa, and you want to get a grade 25, meaning that you want 25 MPa at 28 days. That's specified strength. But you know, nominal, you need to have 20% higher. 1.2 of that might take you to maybe 27, 28. Is what you want to get at 28 days. Then we'll start with a mix design. I've sent something in the chat. So if you look at that chart, what you're aiming for is a C25 or a C30. You can see that the maximum cement you need, minimum cement you need is 275. for a part if it's reinforced concrete. It's stated there in the code, but we only look at this when we want to do our L over D ratio OP, if we want to do our design. But all of these things are easy there in the code. So once I have this, I can do my trial mix. Once I run my trial mix and I know, and I get this strength in my trial mix, say I use 6-7 bags of cement, and I get it right perfectly. What do I need to do? I take proper documentation, proper record, and I ensure the same process is followed on site. Remember, I use the 42.5 Dangote cement. It is not on the day of casting, my supplier will now drive somebody and say, there's a 32.5 cement that is cheaper, and I change. It will switch my result also. Or on that day when I was doing my mix on site, they said, yeah, 34. Sorry, I'm speaking for the other guys. That I'm out of sand. Then you got sand from elsewhere. You're already changing the property of that particular trial mix you've done. Or I'm changing my granite. Before I used 3/4 upward, but now I'm doing 1/2 inch downward. So I'm altering that process. So ideally, to ensure that you get good quality on site, quality control needs to be hands-on. You need, like Engineer Giwa said, you need an inspector dedicated to this. If the mix is not right, you can only vibrate and try as much. It can only make you work. But if it is right, then you can now place it properly. So it's possible. I've seen people pour a full trailer, 4 of it in a day by hand mixers on site. Quality was perfect. There was somebody monitoring each of the machine, and they lined up the casters. You take cement, 2 people on sand, and next 4 on granite, and somebody ensuring that the water is fine. In all of these issues, most times you don't have issues with cement, sand, and granite. Where you have issues is the water. So how have we been able to curb this in some places? What we've done is, imagine that this code told us that in this code I've sent in the chat, said for maximum water cement ratio for reinforced is 0.65. But guess what? We will take a bag of cement in head pan, and the woman carrying water, I would ask us, she carries a bucket of 20 liters. Do 20 by 25, your water cement ratio is going to 0.8 or almost 0.9. But the code is saying maximum water if you use is 0.65. So you see where the issue comes in. So what we do is we put a hole inside of our bucket, and so if you put in too much water, the water will pour on our body, and we can ensure we monitor that concrete. So thank you so much. I think I will stop there. Thank you. Yes.
All right, thank you very much. That's clear enough, and is highly educated. All right, I would like to ask this question, and this question will be directed to both Engineer Giwa and Engineer Shola. So, can we actually trace the incessant building collapse in Nigeria to bad concreting? Do you get that question? We've heard cases of building collapse here and there in different parts of the country. Can we trace this incessant building collapse in Nigeria to bad concreting?
Should I go first, or you want Engineer Giwa to go first? I think I should go first as the material person. Engineer Giwa can come after me. So it's a different thing to have a good product. It's a different thing to use it properly. Like Engineer Giwa has mentioned, I can give you good concrete, but if you don't place it properly, you can also mess it up. So you understand? So I can give you good ingredients to cook a fore for me, but if you don't have the craftsmanship in using the fore, you can mess it up. So once again, I want to share that I lost my best friend in the University of Lagos because of this bad concreting on a multi-story building in Ikoyi. The guy is late now, because we saw in some buildings even doing non-destructive tests. Concrete that was supposed to be 40 was 25. The difference is clear. And buildings that are supposed to go 10 floors went 16 floors. So we understand that this is trouble in the making. And you will see that this concrete was not properly done. And so what can be responsible for this? If you look at it, the major material used by civil engineers, aside water, is concrete. It's the most used material in the world now. They say water is what is the most used after it is concrete. And with concrete, many things can make us get it wrong. Most times our structures are reinforced concrete, but reinforcement is tailor-made. We all know you cannot manufacture reinforcement on your own, but you'd only do 10 or 16% in your reinforced concrete. I think it's even less, like 6-7% is reinforcement. The balance is concrete. So if you get the concrete metrics right, then there's definitely is sure that there will be a collapse. And there are tendencies, there are opportunities that we can get it wrong. Because most times we leave it in the hand of casters and we don't actually pay details or we don't pay attention to it. So I would say it's a possible. Most of this that happen, you see that it has to do with bad concreting, either from the mixing itself, from the design one, from the trial mix, then from the product produced, then also from the placing. And also at times we don't even take sample to check this. So 100% I agree. Most of the collapse we have comes from bad concreting. Thank you.
All right. Thank you very much. Okay, engineer Giwa, what do you have to say to that?
Okay, thank you, engineer. Yeah, I think I want to make a comment from what engineer Shola said initially, but I think I've lost that. Let me quickly attend to the question that you asked right now. So I will use engineer Shola and our vendor as a case study to further corroborate what engineer Shola said concerning the usage of concrete. Let me start from the advanced one. Even people that they have the capacity.
I will talk to you later. I'm in a problem. I'll call you. I'm using this network. I will call you back.
Give them those materials. The way they use it is not proper because they don't inculcate quality into their process. Let me give you two examples. There was we took armatures from engineer Shola and maybe Kioning compound. And when we are using it for our batching plants. And we are dosing it appropriately. And we do carry out tests at a specified interval, and we do have a required strength. The same admixtures that we took from them, they supply another people that they are complaining to me like, these people, the way they use their own admixtures, they are not getting the required strength. That same material. Another one is from the vendor that we do to concrete. They said, you guys, we are supplying someone that is doing similar product as you guys. But when we take concrete to their site, instead of them putting fertilizer, their own method is to put water. And what are part of their own quality control. Because of it is a good example, that's what I want to mention. The concrete vendor is Labat. They said because of they have their own quality control on grant, they will have to tell them, okay, you have to sign on that you are the one, because their driver won't allow them to put water until when they sign. That you have to sign that you are the one that want to put water to the concrete that will weaken your concrete. So you see, those are the things. And going back to the question, it is, when we say building collapse.
Engineer Giwa, please answer this question in 30 seconds, please.
Okay. When we say concrete, when we say building collapse, building comprises of reinforced concrete. There is no way you can do without concrete in building. So, and if a building should collapse, you should know there is a default in the concrete, not only reinforcement. So there might be in reinforcement as well. But the way they handle even there are some people that doesn't have engineers on site. to monitor them. And the people that have engineers on site, what are the quality control measures they put in place? Even there are so many projects that they did not source for their materials, they did not source for their sand, for their granite. There are sand that have too much seed content. And when you have too much seed content in sand, the granite is not well graded. The shape is bad. Maybe the shape is round.
Thank
The
you,
standard of the stone is very
Engineer
bad.
Giwa.
The pH of the water. Okay, thank you. Yeah.
Can everybody see my screen?
Yes, sir, we can.
Yes, this is a particular project in Lagos Rail Mass Transit, one of the overpasses. Engineer Giwa, I'm putting this question to you. Look at this first picture, second picture.
Can you click into the picture, sir? Can you just make it bigger because it's small?
Okay. Do we see it very well? Hello.
Just click one of the pictures so we can view.
I've clicked one, so I don't know if it's showing already.
It's not showing. Maybe you can right click and click view.
Why? So nobody can see my screen now.
We can see the pictures, but they are small.
We can see it, but they are small, yeah.
But I'll make it bigger. I'll make it bigger.
The pictures are not opened now.
Well, it's showing on my screen. I don't know what the problem is.
So on your folder, you can click view and make them bigger.
Full screen. I make it full screen. Can we see it now?
I think there's a delay in your network.
Okay. Actually, I don't know. Maybe I will send the picture in chat. What I actually want to bring out from this is I have shared this picture with you before, Engineer Giwa. So I want the audience. What have you done better? Because there is a particular overpass in Lagos. I won't mention that site, but I have put it to you. What do you do better that you have a better concrete in motion in your placing, in your compacting, curing, batching, and okay, you get your concrete as ready made. So what do you do better than others? Because we have 4 particular mass transit, which are the overpasses, and the projects you manage as a project manager has one of the best concrete in motion. So I want you to tell us, what do you do better than others? Do you do anything better than them? Thank you.
It's a simple answer, and that's what we have been discussing since. So it all started from the concrete itself, so which is quality control. That's it. That's the basic things. Then when we want to expatiate on the quality, that's when we now be talking about, okay, which kind of products you get. Like I will tell you, there are some products, they might be cheaper than some other products, but they are not as effective as that product. And there's we use 2 vendor on that, because pre-qualification is also very important. Even, because we are working in a large scale in that project, that's why we are using fender. We also have our batching plan. I also use hand mix, even with shovel. I normally use stationary concrete mixer as well. But pre-qualifications of fender, initially, while we are doing foundation, we are using 2 fender for concrete supply because we need the job to be delivered on time. So I personally wrote to our top management that I disqualify the other fender. Why? Because the first fender, when I do my when I crush my cube, it always give me higher grade. But the other fender, it should be exact. It should be exact or a little bit lower. Maybe I need grade 30 is giving me 29.5, 29.6. You understand? So Then I said, I'm not using this vendor anymore. It started from pre-qualification if it is on large scale. But if it is not on large scale, you are preparing concrete by yourself. You have to look at it from the start, where you start sourcing from your material. That's where I stopped the last time. You have to source for a good sand, a good stone. I said the property of the sand is look at the seed content, the stone shapes and the sandness of the stone. Look at the water, the pH level of the water. Look at it. And then you have a good mix design. After having a good mix design, you go to the lab and conduct a trial mix to ascertain that that mix design actually give you the grade that you wanted. You understand? So after then, you go to the issue of we have discussed mixing when you want to place. So when you want to place your concrete, the vendor might put retarder. The retarder also has its own capacity. You have to know when concrete now, when you want to cast concrete, if there is no retarder, 3 hours, the concrete might have failed. So when they put retarder, you have to get the data sheet of that retarder to be sure of when is it retarding the quality too. So when you get that, you must make sure that you must pour the concrete within that time. After then, when you have your concrete on site, don't put water. It comes with plasticizer. Instead, if you need more work, if you need your concrete to be more workable, put plasticizer instead, and make sure you put your personnel, quality personnel. Make sure that it's not every jig and alley that we always go to the truck, on top of the truck, and say, okay, is it workable? Yeah, put water, put this. Let there be a specific person that will check your concrete when it comes to site to check the workability. Then, when you want to place, you look at, we are not talking about the quality control of about the inspection. I will not talk about, let me be specific on concrete. When you want to place, you make sure that you have the best of the mason on ground that understand the way they place concrete. And I said it earlier that even people, there are so many people that doesn't know how to use the poker machine. So you have to train your people to know how to cook it. If as Engineer Shola said, there are some like CFA or PI that requires CFA that requires high slump of concrete. So there are some other elements as well, like when you want to do post-tension beam. So because of the reinforcement that too and the pipes, the ducts that you put in the post-tension beam, you might not want to vibrate very well. You understand? You might go for self-compacting concrete. Then, but you still have to vibrate a little bit. There are so many vibrators you can use at the panel, but you can still use your poker as well. But you have to set it. You have to set it. There's a way you set it. So with so many other things, like your quality control people on. Okay, let me stop.
So I actually know you have so many things to say, but trust me, if we allow you all day, we will be here throughout the night. So let me quickly ask this question, even as I allow my audience to join us in this discussion. I have enough questions, but then the time is not on our side. So one, let me ask this. I will ask you. So what do you see as the biggest challenges facing the concrete industry in the next, let's say, 5 to 10 years? So, Engineer Sola, I would like you to come first. Then Engineer Giwa.
Okay, thank you. So I would permit me to just say, first thing is, they say ignorance is not an excuse, it's knowledge. I would just show briefly my screen. It's knowledge. If you can see it, let me know. It's just to share my screen and just show you something that would help.
Yes.
I will share a screenshot of it.
From this.
Yeah, so I'll put a pen and I'll tell us how, or this laser. This is compressive strength of 20. But you can see if you want to get a compressive strength of 20 and your water cement ratio is 0.4, you can get it earlier. You can get it at 1 day. You can see this line I'm showing. You can get it at 1 day. But if you increase that water cement ratio, like we've all mentioned, from 0.4 to 0.6, that means you are moving that strength value to 7 days. So you see the effect of water cement ratio. But this is water cement ratio, as I'm saying, not just water alone. So it means I can reduce my water and I can also reduce my cement. Understanding that in concrete, the most expensive element is cement. I don't know if there's somebody that has a plug where I can buy cement cheaper. Maybe you can send me your number in the chat. But so you can swap your water and your cement. So what is challenging now for us is knowledge. And I would say also legislation. So just to close it, there will be knowledge and legislation. I'll tell you in some countries of the world, they don't allow people to make concrete. You would only buy concrete from a ready-mix producer. You are not allowed to make concrete on your site because you cannot be the designer, the user, and also the maker. Then who is checking you? There's nobody checking you. So there are legislations that also prevents people from making concrete. Look at Nigeria, just anybody can make concrete. And it's the most used civil engineering material. And so, but anybody can make it. If I buy cement, buy granite, I can mix it myself and I can make it. To what design, to what specification. So I think the challenge, like I mentioned again, is one, legislation is one, then also two, knowledge there's a big knowledge gap. People are not investing into material science, material knowledge, and we don't know so much. And just to go back to Engineer Giwa, you mentioned collaboration, is that we also don't want to collaborate. Because I'm a structural engineer does not mean I'm a material engineer and I know concrete. You will see that certain companies, they have different people doing different things. And I'm sure on Engineer Giwa's project, they had many, many collaborations. I know one of the reasons why he had that fine concrete also was because they used a very, very magnificent framework. And he had a big company, a specialist company that actually did that for him. So knowledge, like I mentioned, is key. Ignorance, we don't know many things. People don't know about form work. You just say put marine board, put this one under, put this thing. So knowledge is a gap for me. Then next, I will say legislation. You can only legislate what you know. So knowledge is still priority for me. Thank you. Yeah.
All right, thank you very much. Engineer Giwa,
Okay,
Okay,
give us
thank
30
you. I
seconds.
will just Okay, thank you. I will briefly say the challenges are part of what Engineer Shola have said is time over quality. That's the challenges I'm seeing because people, even in large scale projects, people want to see your project delivered at the expense of quality. Even when they are seeing your quality, I see a company that is handling a very big project. They put water into concrete, and after they cast, their finishing are very poor. There will be a lot of segregations and cracks, and because they want to deliver that kind of project, the consultant, everybody, they will just look away. You understand? That's the challenges I'm looking. If care is not taken, people will be because we want to deliver project on time and look away for quality. So that's it.
Thank you, Engineer Giwa. Balogun Moshood, your question in 30 seconds, please, or your contribution because of our time. Then Olawole Shola should be ready. Thank you. It says Balogun Moshood is not online. Olawole Shola, unmute your mic and ask your question or whatever
Good
contribution you have.
Engineer
Yes, we can
Shola.
hear you. Go ahead.
Can you hear me? All right, thank you very much. Thank you for the highly impactful session. I really appreciate being part of this. So my question was actually answered by, I think, by Engineer Giwa. But let me tell you about one of my bitter, terrible experience with concrete. During one project, I was meant to produce some trench cover in one of the sugar producing companies in Nigeria. So, and during that process, my supplier, my vendor, carelessly dumped materials on top of the raw sugar, both the granite and the sand. So we eventually did the casting, the concreting, and we realized that after many weeks, the concrete refused to set, get added. So I later realized that maybe they actually going to be some content of sugar, which made us to relax the striking of Tonwo for another 4 weeks. so making 8 months, but yet the concrete did not actually set. So this is my question, because at the end of the day, I had to break the concrete and start it all over. So my question is that was it going to set if I had leave it, or is there anything? Is there any possible reason that that we can actually get some concrete set maybe over time?
Okay.
Good,
Engineer Shola.
good insight. It's quite unfortunate for you. But sugar is actually a retarding agent. It's a raw material for producing retarder. And also you add a little bit of it inside of plasticizer for self-retarding plasticizer. But remember I said that, and Engineer Giwa has also mentioned, one needs to be careful in the use of retarder. If you make a mistake in using it, then whatever has happened to you would happen to anybody. But like you mentioned, we have also seen a project where they waited for 4 days, and in 4 days he began to gain the strength, and in 28 days he did gain all of the strength. But time is also a value that some customers want. Like you mentioned, it's a sugar refinery. You know how much cost these people run in a day. So time is money. They might not want to take such a risk. And I don't know the amount of sugar that is there. I've not done a test on. You will use 1 kg of sugar in a cubic meter. This is how much of retention time you can get or retardation you get on when you set. So, except we have the basics, but I wouldn't know. But standard QC procedure says that concrete should set in 20 to 22, maximum 20 to 22 hours. You get. So if it does not, then it's extreme. So I
Thank you so
think
much, sir.
that's the procedure.
Thank you
I
so
will
much,
work
sir.
on it. Thank you.
Issa Bukoye, your question, please.
In 10 seconds, please.
Good evening. I'm grateful to be part of this. My question actually is, should I say the question or something? What I discovered so far, like this fixed mix ratio, like 1:4, 1:6, and all that. I saw that lately, with all that, we were unable to get the result, like like the intent strength of that particular concrete. Now, this is the issue that I'm having. About 3 months ago, there was a site at visited. The man was complaining about honeycomb in the concrete and all that. So they were like, what can they do to reduce that? Now they are they have a concrete mixer on site, and they have a caster on site as well. So